The front 1.20 meters of a 1,400 kilogram car is designed as a crumple zone that collapses to absorb the shock of a collision. If a car traveling 25.0 meters per second stops uniformly in 1.20 meters, Part A, how long does the collision last? Part B, what is the magnitude of the average force on the car? And Part C, what is the acceleration of the car? Express the acceleration as a multiple of the acceleration of gravity. Okay, so I drew a picture to illustrate this question. So here's the car. The front 1.20 meters is the crumple zone. So before and after the crumple zone is completely gone, and the car has stopped uniformly in 1.20 meters. So to find the time initially, I used kinetics, and when you figure out that each piece that you have, you realize that you're missing a piece, and you can solve for acceleration to find time. So the final velocity is 0 because the car is completely stopped uniformly in 1.20 meters. The initial velocity is given, 25 meters per second, and the change in distance is delta x, and that's the 1.20 meters that crumpled. So we plug everything in, and then we solve or divide 25 squared, and then 2 times the 1.20 meters, and then we get negative 260 meters per second because I set this direction as forward and the acceleration is going backwards. Then I use this final velocity to get the time. I rearranged this formula, plugged in the numbers, and got 0.096 seconds. Now, for part B, the force used, I used F equals ma, and I used the acceleration that I found in part A for part B, and then I just multiplied it by the total mass of the car, which is given in the question, the 1,400 kilogram car. So then I multiplied that by the final velocity and got this huge number. And then finally for part C, the acceleration of the car is what I solved for here. So taking this first step really helped me to solve both parts B and C and made everything a lot easier. Good luck, physics people!